Good morning. I'm Dr. Janardhana Rao. So we are discussing about mass storage structure and how the file is saved, the file systems. And today we are discussing about disk scheduling. What is disk scheduling? Before this, we have seen that what is disk and what is mass storage and all. So a process needs two type time, that is CPU time and IO time. So for IO, it requires the operating system to access the disk. So however, operating system must be fair enough to satisfy each request, and at the same time, operating system must maintain the efficiency and the speed of process execution. The technique that operating system uses to determine request which is to be satisfied next is called disk scheduling. So as we know, whenever we want to save any file, as for the file length of the file will be saved in the disk, different disks. Hard disk, in the hard disk, there will be number of, just we assume that there will be number of CDs type with a bunch of some 300 CDs are set like this. So in which track or which sector which CD or file is saved. So once the file is saved, when you want to retrieve that file, it's automatically the same way how the file is written there, and whichever the CDs are used, disks are used. And in the same way, we can retrieve the data from the hard disk in term by term, or you can see step by step, or you can say on which CDs the data is saved. So as for the sequence, the data will be read from the hard disk step by step. So that is a disk scheduling, and what are the disks are used for saving that particular file. So they will be linked together. So already we have seen linked allocation and sequential allocation and all these things. So today we will see what is disk scheduling. So some important terms related to disk scheduling. Seek time. Seek time means we have to position out the CD under the read head height. So seek time is the time taken in locating the disk arm to a specified track where the read and write request will be satisfied. So already we have saved our file in the hard disk. Hard disk is consist of number of CDs. You just imagine. So on which CDs our data is written, where our track, which sector is used to save our data. So that is that may be positioned under the read and write head. So by the time the CD will be rotating, whenever you want to open that file, and that position will be from where you have to read the data, that will be positioned under the read and write head. So we will listen some moving sound inside the system, or whenever you want to read the file. That is the thing, we are positioning that CD or disk arm. We are rotating the disk arm, rotating the disk to the read and write head. That is called seek time. Rotational latency. It is a time taken by the desired sector to rotate itself to the position from where it can access the read and write head. So as we have seen in the mass storage structure, disk arm and the disk, there will be spindle. This is our hard disk positioned like this, and this is our spindles, and this is a read and write head. So whichever the file is saved on which disks, so that will be rotated. That corresponding CD will be rotated to that read and write head position. So that is latency time, rotational time, you can say, rotational latency. So almost it is time taken by the desired sector, actually where our file is saved, and which sector, you know that we have already discussed. This is our CD. So there will be tracks and sectors, and which sector our data is written there. So that will be positioned under the read and write. Suppose our file is here and read and write head is here. So this will be rotated to that particular position. So that is the sector will be positioned under the read and write head, so that we can read our data from the disk, you can say, a disk. So the movement of this angular rotation, CD will be rotating to that position. So that is the thing. Then transfer time. It is a time taken to transfer data. Whether when you are writing or reading the data, so whatever data you are writing, so how much time it takes to transfer from RAM to your hard disk. So transferring the data. So same way, our data should be, when you are reading the data from the hard disk, so how much time it takes to transfer from hard disk to your RAM. Or once you may, it is coming to RAM only. Whatever is coming to RAM, then only you can see that one. That is the how much time taken to transfer data from hard disk to RAM. So disk access time. So disk access time is given as disk access time is rotational latency plus seek time plus transfer time. So this is the thing. So whenever you want to read any file, the OS will locate on that file where it is saved or written. So that's time plus positioning the that one to your read and write head. So that read and write head can, CD will be rotating. So these are all things, transfer time, all the things you have to add, then only you get disk access time. So disk response time, it is the average time spent by the each request waiting for the IO operation. IO operation is nothing but input out operation. How much time? Disk response time. So disk is response, how much time it taking to respond to do all the above. That's our disk response time. So purpose of disk scheduling. The main purpose of disk scheduling algorithm is to select a disk request from the queue of IO requests and decide schedule when the request will be processed. So as you know that, once you save the file in a hard disk, so if the file is big one, how many, maybe it may be saved in 2-3 CDs or 2-3 disks. So which sector we have utilized that one? That's so goal of task scheduling, disk scheduling is fairness, high throughput, minimal traveling at time. Because head is this is our read and head, right head only can read the data from the specified location, a specified sector, specified track. So minimum traveling head. So you should not opening the file. You should not take 1 hour. So that is a minimal traveling head time, high throughput. So you must be get the job very fast, very high throughput should be high. Fairness, there should not be any error in reading the data. So whatever file you have saved in the hard disk, the same file we can get it done from the hard disk. So that is the thing, goal of disk scheduling algorithm. So what is disk scheduling? The operating system is responsible for using hardware efficiently for disk drives. This means having a fast access time and disk bandwidth, and access time as two major components. F-seek time is the time for the disk or to move the heads to cylinder containing the desired sector. F rotational latency is the additional time waiting for the disk to rotate the desired sector to the disk head. And minimize seek time, and seek time is seek distance n disk bandwidth is total number of bytes transferred divided by the total time between the first request for a service and the completion of the last transfer. So this is we should minimize all these things. So we'll see what are the disk scheduling algorithms. So the first list of various disk scheduling algorithms is given below. Each algorithm is carrying some advantages and disadvantages. We will see the limitation of each algorithm leads to the evaluation of a new algorithm. So suppose in one algorithm there is a problem, there are some disadvantages and some drawbacks are there. So automatically we'll go for the another invention of the algorithm. So we see there are disk scheduling algorithms, FCFS, first come first serve, and next one is SSTF, shortest seek time, first algorithm, and scan scheduling, C-scan, look scheduling, and C-look scheduling. These are the disk scheduling algorithms. When you want to save any file, So it will follow these algorithms also. When you want to read the data from the hard disk, that time also they will follow the same pattern in same pattern. While writing, in which disk we are selecting to write the data, and while reading also, how the same reverse. So we will start the where the data started writing and which disks are used for the writing the data. So we'll see one by one. So the first one is disk scheduling algorithm, FCFS. FCF first come first serve. It is a simplest disk scheduling algorithm. It serves the IO request in the order in which they arrive. There is no starvation in this algorithm. Every request is served. So what are the disadvantages? The scheme doesn't optimize the seek time. The request may come from different processes. Therefore, there is a possibility of the inappropriate movement of the head. So example we'll see. So actually, consider the following disk request sequence of the disk with the 100 tracks. So this is a 45 is one disk and so 21 is one disk, 67. Just imagine like this. So head pointer starting at 50 and moving to the left direction and find the like this. So if you look at this diagram, initially the head is at 50. So rest of the request queue is 10, 95, 23, 78, 80. So this is a tracks, rather you can say tracks, and these tracks your data is saved. So as you know, data is saved in the different disks and different sectors and different tracks. So initially our head is at 50. So now next first come first means next one is 10. So automatically from head that your cylinder or your CD or your you can rather say disk will move automatically. There's that angle rotation. It will change its position from track 50 to 10. So we'll find some movement or some angular movement of the disk inside the system. So now it goes to 10. It goes to 10. So as it is given here. So 10 from there. What is the next one? That is 95. So automatically, as a name suggesting first come first, so it goes from 95, 9 after 95, after 95, 23. Again it comes to 23, 23. So next to 78. Automatically it goes to 78. So from 78 it goes to 80. 80. This is how the disk is making movements as per the given queue, request queue. So this is, so it will read the data from the tracks, different tracks. These are the track numbers you can say. So this is very simple, first come first serve. So it will read the data from the different tracks and it transfers to the RAM so that whatever is available in the RAM, the user can see the data in the screen. So that is how the file is read from the hard disk to the RAM. So this is how the OS will monitor, how the OS will provide the movement to the particular CD to read the data from the particular track. So if you look at this one, when it is moving, it is simple example. So number of cylinders moved by the head. So initially, this is another example. So initially at 50, it moved from 50 to 45. So how many cylinders? 50 minus 45, 5 cylinders, and from 45 it moved again to 21. So 45 minus 21 plus 6 from 45 or from there it moved to 67. 67 minus 21. From there again it moved to 90. So 90 minus 67. So again it moved from 90 to 4. So 90 minus 4. And then from there 4 to 50. So 50 minus 4 plus from there it moved to from 50 it moved to 89. So 89 minus 50 plus from 89 it moved to 52. 89 moved to 52 like this. From 59 it moved to 61. From 61 it moved to 80, again 87. From there it moved to again 25. So So we will subtract each time from current location to how many jumps or how many tracks, how many cylinders it moved. So that's it. We will do. We will add all these numbers 5 plus. So 50 minus 45, 5, 24, 46, 23, 86, 46, 39, 37, 9, and 89, 87 minus 25. You will get 62. If we add all these things, we'll get the figure for 403 cylinders. It took to move all these cylinders inside and get the data from the hard disk to your RAM. That is, it is reading the data from the different tracks where it is loaded. So all these things it will read, and it will transfer the data from hard disk to your RAM. So this is first come first. So if you go to another one, SSTF. SSTF means shortest seek time first. So shortest seek time first algorithm selects that the disk IO request, which requires the least disk arm movement from its current position, regardless of the direction. It reduces the total seek time as compared to the FCFS. So it allows the head to move the closest track in the service queue. As it is first come first serve means in the queue, what is the next track number or disk number, that will be positioned under the read and write head. Automatically the cylinder, or we can say the disk, will move. So here what are the disadvantages of this SSTF? It may cause the starvation for some requests. Switching direction on the frequent basis slows the working of algorithm. It is not the most optimal algorithm. So we'll see how it is working. So if you look at this one, disk algorithm of SSTF, see, consider the following disk request sequence of the disk with 100 tracks. So the 45, 21, 67, 94, 89, 52, 61, 87, 25. So here, at pointer starting at 50. At pointer starting at 50. Here, 50. And what is that? These are the requests are made. So to the 50, which is nearby, that we will see. So it is 45 is nearby. 45. So from 50 it moved to 45. So after 45, what is the next 52? Again, it is 57. You don't follow the sequence here. So it will see what are the number close to that header that will be positioned. That cylinder, rather you can say, the track will be positioned under the read and head. So next is 52. So it will move to 52. So after that, what is the next? Near to the 52. So after near to 52, next one is 61. So it moves to 61. Like this, the current position to the current position. What is the request in the queue? So which number is nearby to the current position? So that will be accessed. That will be positioned under that cylinder. Rather you can say that track will be positioned under the read and write head. So like this, the track cylinders will be moving. So ultimately it reaches the end last position, that is 4. So that is like this. So meantime, the number of cylinders, how it is moving. Initially at 50, it moved to 45. So 50 minus 45. So like this, it keep on subtracting from the initial to next jump, and we will add all these things. We will get 136 is the cylinders. How many jumps it made, how many cylinders it made to move. So that is 136. So this is the shortest or minimum from the current position. So that is SSTF, and we'll see what is the next one. So in the SSTF, select the request from the minimum seek time from the current head position Current SSTF means shortest from the current position. That is SSTF. So next one is scan algorithm. In the scan algorithm, it is also called elevator algorithm. It is called elevator algorithm. In this algorithm, the disk arm moves into a particular direction till the end, satisfying all the requests coming in its path, and then it returns the back moves in the reverse direction, satisfying requests coming in the path. So we'll see that example also. It works in the way in elevator works. Elevator moves in a direction completely till the last floor, so the direction and then turns back. So we'll see. So as the same example, so this is a request for our reading the file. So here in this tracks only, our in this cylinders our file is saved. So we will see each cylinder how it moves. So in this one, if you look at this example, so initially starting head is 54, head is at 54. Now, so in this one, as per example, in this example, if you look at this one, so 65, 78, it will move to one direction only, one direction. So it will go to 0. On the way, 14 is there. On the way, 14 is there. It will touch the 14 and goes to 0. It will go completely end. So next, from after going to reaching the end, again it will go to reverse direction, this direction. So last cylinder. So like this, it will touch the one end and goes to end. Again, it goes to end like this. It is scanning. It is just like it works like elevator like a lift. So it goes to completely on the direction, one direction only. After on the way, it reaching the direction. What are the cylinders available? It will touch that cylinders and read the data from there. Or tracks, you can say. The next, if you same way, you can add the differences from the current to the next cylinder. So how many cylinders it jumps? That is, if you add all these things, 40 plus 14 plus 65 plus 13 plus 20 plus 24 plus 11 plus 4 plus 6, 46 to 37. This is your scan algorithm. So next, this is the same example. The disk arm starts at one end of the disk and moves towards the other end, serving request until it gets the other end of the disk. So where the head movement is reverse and servicing. So it will start here, it go to end. So from there, it go to another end. This is scan, what you have seen in this example also. So scan algorithm, sometimes called elevator algorithm, already you have seen it. Next one is C-scan. Next one is C-scan. The arm of the disk moves in a particular direction, servicing requests until it reaches the last cylinder. Then it jumps to the last cylinder of the opposite direction without serving any requirement. Then it turns back and start moving in that direction, serving the remaining requests. Consider the following disk request sequence for. See, what is the difference between the scan and C-scan? Just we'll see in the scan, the arm goes to last cylinder and come back in the direction whatever it is there, it will serve it. But here it will not go to last. Only difference is this one. This one is difference. See, it goes to it initially starting at 53 and it goes in this direction. In this direction, and even the cylinder is there, it goes. If cylinder is not there, it come back from there like this. So what is the difference between when it is going up one direction, it will serve the other disk. So after reaching there, it will jump back again and start. This is the only difference between the scan and C-scan. C-scan. In the scan, we have seen when it is going in the reverse direction, it will serve some disks also. But here, it won't serve anything. It will jump from one end to another end. Again, it will start scanning. So that is only difference between this scan and C-scan. So This is a C scan. If you find these two diagrams in the scan, you will find like this. It will like this. It will go to other end, and it will serve in the reverse also like this. It will serve all the one cylinders. Whereas in the reverse direction, it won't serve in the C scan. So that is only difference between scan and C scan like this. We don't serve anything blank. Whereas in the scan, it will serve some of the also in the scan, but in the C scan, it won't serve in the reverse direction. It won't touch any cylinder. It goes to the end of the end, and from there, it will start serving the tracks or cylinders. So that is only difference between scan and C scan.
Like, share and subscribe. Hit the bell icon for more updates.